Okay, so hey guys, welcome to BayTutors Intermediate Advanced Programming Camp Day 1.
And we're excited to have you guys here with us today. And we have a lot of interesting material prepared for you guys, and we're excited to teach it to you.
Okay, so with that, we'll go ahead and start off by sharing my screen so you guys can view the slides. Okay guys, so our agenda today, first off, you guys will be able to meet your instructors. Then we will cover data structures and variables. Then we'll be moving on into Boolean algebra and then complete with conditional statements and loops. And just as a quick reminder, all of this this first week will just be a review week of basic Java concepts, just to ensure that all of you guys are well prepared for the next couple of weeks, where we'll be transitioning more into the AP Computer Science curriculum that you will likely cover in high school. So to begin with, we'll go ahead and go for the first topic for today. So hi, my name is Shrinandan Narayanan. I am a rising junior at Cupertino High School, and I've been coding for over four years now. And I started my coding journey in Java itself in around 7th grade. So Java was definitely one of the first languages I learned, and I believe it was the best thing for me to do at the time, since it's a relatively easy language to pick up and just teaches you the fundamentals of programming. So it's a really good language for you guys to learn, and it's really great that you guys are interested in learning it through this camp at such an early age. So I'm super excited to start these lessons with you guys and start teaching you guys Java.
All right, so yeah, hi, I'm Arnav, and I'm also a rising junior at Tino. And similar to Nandu, my first language is also Java, and I learned a lot of my Java skills through taking the APCS class at school. And I hope to inspire you guys and teach you guys the skills necessary. So let's get started.
Okay. So just a couple of overview of just a couple of necessary materials that you guys will be required to have for this course. So we recommend that you guys have Eclipse. You guys don't need to have that installed right now. You guys can go ahead and install it maybe after this class or before, at least before Wednesday or by Friday of this week. I believe in the email that we sent out to you guys, we have also attached links to download Eclipse if you're on Mac or on Windows. So please go ahead and do that. In the case that you're unable to install Eclipse, you guys can always use REPL or Replit. It is an online IDE that I highly recommend for you guys to use. It also has like the possibility for you to create multiple classes and sort of work in a similar IDE environment to Eclipse. So if you guys would like to use Replit, that's perfectly okay. And you know, if you guys, and throughout these lessons, we will also be doing, teaching you guys different ways of how to implement stuff in programming. So if you guys would like to try that, just like while you guys are watching the session, please feel free to open up Replit in like another browser and just follow along with us. So that's a really good thing to do. All right, so now moving on to our first topic of the day, which is going to be data structures and variables. Arnav, I think you're muted.
Yeah, all right. Yeah, sorry. Okay, so variables are essentially a piece of memory that allows us to store certain data values in Java. And some examples of variables or data types that we use in Java are integers, strings, characters, and booleans. And basically within variables and data types, there are two types, and we classify them as primitive and objects. And for today, we'll only be focusing on the primitive data types, which are like integers, characters, and booleans.
Yeah, and as mentioned, variables are a piece of memory. So essentially, for example, the integers takes 32 bits in your memory and so on. Okay, so moving on. So we mentioned that we'll be focusing on primitive data types just for today, and later on this week, we'll be covering objects. So primitive data types are essentially just predefined types of data that are ready for you guys to use in Java. And in total in Java, there are 8 primitive data types, which include Booleans, which are essentially true or false, binary values, Booleans, bytes, chars, characters, which is essentially a Unicode character, so sort of like a letter, like A, B, C, or D. And notice the single quotations that is used, the syntax that is used to specify a character. There are shorts, there are ints, which are also whole numbers. For example, 7, a whole number integer, so it can be a positive or a negative whole number. So like 7, 6, -5, and so on. Shorts doubles, which are essentially decimals. So like 4.5, so on, can be positive and negative, longs and floats. And in this course, and in general, when you're programming, you will be primarily working with the data types that are bolded here. So that would be the Boolean, the character, the int, and the double.
All right, so when you're creating and trying to store a value within a variable, there are two steps, and that's declaring and initializing. And looking at declaring a variable has two steps, and the first step of it is setting the type of variable you want, and that's like something such as an integer, a double, a Boolean, or a character. And then the second step is deciding what you want the name of the variable to be. And for example, if we wanted to declare an integer called x, we would do as follows on the screen. So we would say int x, and that declares a variable of type int called x. And note that although the full name is integer, in Java, we shorten it down to and call it int. And like similarly we do that with characters, like we shorten a character to like char, and double just stays double. And you guys will like learn that as we go throughout the course. And note that the name of the variable, like x, it can only include letters and numbers, and that can include capital letters, but it can't include spaces or special characters like slashes or like periods or commas. And then initializing a variable has one step, and that's just setting the variable to an appropriate value that corresponds to the data type. And for example, we previously talked about declaring an integer variable called x, and here we're declaring it, or we're initializing it to 5 by saying x equals to 5. Or we can also just do it in one line instead of doing it in two separate lines by saying int y equals 5, and that in one line we declared and initialized the variable. And note that at the bottom of the screen, we can see there's a wrong example of declaring and initializing, and we say integer z equals to 3.14. That's actually wrong because 3.14 is actually a double or a decimal and not an integer, so that would be considered wrong and you'd be throwing a compiler error.
Okay, yeah, and on the right, we have some more examples over here of correct implementations of declarations and initializations. So as you can see, the first one is Boolean is correct is equal to true, and that is obviously correct since the Boolean has a true or false value, and this is initialized in one line. Next one is int num equal to 7, which is correct since it's an integer. Double pi val 3.14, blah, blah, blah. We have the character letter, which is equal to a. And once again, notice the single quotes as well as the letter, just one letter inside. And it's not like it's not like a word or anything, which is considered as a string in Java. And these are just like a bunch of other correct examples of how to properly declare and initialize variables in Java. And down here, we have some wrong initializations, which should be quite obvious to you, considering that you should have prior experience working with Java. So over here, as you can see, Boolean is very wrong is equal to 284. Obviously, that is an integer and not a Boolean. Char phrase is equal to hello. That's actually a string and not a character. So that is another wrong implementation. Int wrong number is equal to 4.18. This actually has two things that are wrong with it. One is the fact that there's a space between the name. So wrong and number, it should essentially be joined and not separated. And it's also a double value and not an integer value. However, we'll be coming back to this, I believe, in the next slide, where we'll be talking about something called typecasting and how you can actually make this statement if you were to join the wrong and number together, how you can actually make this statement actually true and correct. Next is Boolean not is equal to wrong. Once again, this one also has two problems. One is that it's a string and not a Boolean. So once again, the value does not correspond to the data type, as well as there's not a space between the data type name and the name of your variable. And sorry. Sorry. Okay, and the last one is char sentence is equal to 341. That's a double. It's not a character. And if you guys do have any questions, please feel free to type it in the chat below, and we'll be able to get back with you.
Yeah, and also note that in the previous slide, with the Boolean not example, we note that wrong is a string, which is an object and not a primitive data type. And we'll talk about that in the future, but that's just something to note. All right, so typecasting is another concept that's pretty important to know. And basically what it is it allows you to change one type of variable to another type of a variable. So you can convert like a double variable to an integer. And typecasting is done by putting the data type of the variable you want in the end in parentheses in front of the variable you want to convert. So for example, if we wanted to convert double pi val, which is that, to an integer, we can do so by typecasting it as such, and we would say int num equals to, in parentheses, int, and then we put the double right after that, and that typecasts it to an integer and allows the integer to be declared initialized error-free. And note that when typecasting to a decimal, from a decimal to an integer, Java always rounds down to the nearest integer instead of rounding to the nearest whole number.
Yeah. And something else to keep in mind, like a small little fun thing, like a simple trick for you guys to use to essentially make that process easier for you is if you're ever typecasting down from a double to an int. So as Arnav mentioned, everything like Java always rounds down when you're typecasting. So something that you can do is essentially disregard everything after the decimal point. So for example, if you have a double like 6.85 and you want to typecast it to an int, the int would essentially just be 6. So you can, it rounds down, but to make it simpler, you can just disregard everything after the decimal point.
Yeah. Okay. So as Nandu mentioned, that's a pretty helpful trick to when typecasting a double to an integer. But there are also other types of typecasting, and generally you should know that when typecasting a smaller data type to a larger data type, Java automatically typecasts it for you, so you don't need to manually do it. So if you wanted to convert an int to a double, like we have in this example, we have integer myInt equals to 9, and then we want to convert that to a double, so we would say int my double equals to my int, and note that we didn't need to typecast it with the parentheses because Java automatically would typecast that for us. And you might be wondering, how would you typecast something like a character to an integer? And you do that through the use of something called an ASCII value. And an ASCII value is essentially a value that allows like characters to correspond to integers. And there's something called an ASCII table, which we'll show you on the next slide. But essentially, each character corresponds to an integer, and that's the way Java typecasts it. So if we look in this example, we have character y equals to y, and then if we want to typecast that to an integer, we typecast it with the integer like typecast notation, and then we just put y behind it, and it typecast it to 121, because if we look on the next slide, the ASCII value of lowercase y, which you can kind of see on the bottom right-hand corner of the ASCII table, is 121. And note that when you're typecasting, you're going to be looking at the decimal value and the character value. You can disregard the hex and oct values because we won't be needing them. So only look at the decimal and character values.
Okay. Okay, yeah, so that was basically it. So if you guys have any questions about typecasting in general in Java, please write that down in the chat if you guys have any questions. Okay, so moving on, we'll be talking a little bit about Boolean algebra, which is a pretty big topic in Java. I'm pretty sure most of you should be familiar with this. So these are these operators, in general, these Boolean operators, which are the and operator, as you can see over here. One second. The and operator, the or operator, the equals to operator, and the not equal to operator. So these are the four big operators that are used in Java, as well as these ones, like the greater than and the less than signs, which are also commonly used in Java. So just to walk through about how Boolean algebra sort of works. So for example, if you were to have, let's say you have two values, right? Let's say you have value A, which is a Boolean that is initialized to false, and you have a Boolean B, which is also initialized to false. And suppose we were to make a statement, right? Such as if A and B, right? A double and B. So that would essentially be as if you saying false and false, or false and false. And false always will equate to false, since the and operator is false sensitive. So if there is a false attribute in the statement, then the whole statement will equate to false. Whereas if we were to do false or false, that will still equal false. And if it's not A, as in if it's not false, then it'll equate to true, since true is the opposite of false. Then moving on to the next value of A and B, if A is initialized to false, but now B is initialized to true, then if we were to look at the A and B, that would still equate to false, since we have a false attribute in the statement. And if we were to look at A or B, however, it would equate to true. And the reason being is because the OR conditional is actually true sensitive. So if there is a true value in the statement, then the whole statement will equate to true. And then again, if it's not A, which is like not A, which is not false, then the final value will be true. Then moving on to the next implementation, if A is equal to true and B is equal to false, then if it's A and B, once again, it's still going to be equal to false, since B in this case is false, and there is a false attribute in the statement. And if you look at the A or B, the A is true in the statement, so, and the OR is true sensitive. So since there is a true value, then the whole statement will become true. And if it's not A this time, since A is equal to true, not A is going to be false. And now for the last implementation, if both of them are true, then you're going to get true for A and B. Since both values are true, there is no false. And for the A or B, you have two true values, which will ultimately make it true. And if it's not A, once again, you will get false, since the opposite of true is false. So down here, we've actually listed some implementations, possible implementations of how this would be used in Java. So here you have true and false. And this will equate to false since you're using the and operator. Then another way you can express Booleans is through statements like this. So as you can see, the 3 is greater than 4. Obviously, that is false. So this will equate to a false value. Oh, excuse my drawing right there. And the 4 is less than 5 is true. So that is a true value over here. So since we're using the OR operator, it'll equate to true, since the 4 is less than 5 is a true attribute in the statement. Then we have the 3 equal to 4. This is essentially saying, is 3 equal to 4? And this would be false, since 3 is not equal to 4. And here we have 7 not equal to 9. Is that correct or false? Well, that is true, right? Since 7 is not equal to 9, then you get true as your return value. 96 is equal to 96. That is true. And true is equal to true. And that is true. All right, so that is just like a quick overview of Boolean algebra. Once again, if you guys have any questions, feel free to type in the chat, or if you'd like to and you're comfortable with it, please unmute yourself right now and ask any questions about Boolean algebra. All right, so assuming you guys do not have any questions, moving forward, we will go ahead and cover our next topic, which is conditional statements and loops.
All right, so conditionals in Java are or if statements, as you probably know, are statements. And in Java, if statements run only if the statement inside of them equates to true. And conditionals can only run error-free if the statements inside of them are a Boolean value. And if they're not a Boolean value, then it'll throw you a compiler error and you won't be able to run your code. And you can check if the statement inside the if statement equates to true using Boolean algebra. If it does, then you continue to execute the code inside the body of the if statement. And in addition to if statements, there are also else if and else statements. And the compiler will, and it's important to note that the compiler will only check or even execute these conditions if the original if statement was not true. So if your original if statement was true and that was executed, then Java will ignore the else or else if statements. And on the right side, we can see a simple flowchart explaining this. And you start off with a Boolean expression, that's the if statement. And if the code is true, then we execute the statement inside of the if body, and then we move on to the rest of the code. Otherwise, if it's false, then we move on to the else code or the else if code.
Yeah, so those are essentially just a quick overview of conditionals. So now we'll be going over some possible examples that might be there. So first off, we have something that says if 6 is greater than or equal to 4, print if executed. Just as a heads up, we just wrote print here just to simplify the code, but in Java, if you want to print a statement, you would actually be saying system.out.println or system.out.print. But here we're just saying print right now just to make it a little bit more simplified for you guys. So here we're saying if 6 is greater than or equal to 4, print if executed. Else, if it's not that, then say if 9 is less than 13, then print this. Or if it's not either one of these two, then you're going to go to else, you're going to print negative, which is like the last thing that you're going to resort to is to print negative. So now let's go and work through this whole thing from the beginning. So if 6 is greater than or equal to 4, which is true, we're going to go ahead and print if executed, and that's what's going to happen. And since this is satisfied, we're actually going to disregard everything else and just move on to whatever's there in the rest of the body. So as you can see, the output will be if executed, which is like the print statement. And that's because this if condition was true. And all the other statements are not checked since the first statement was true. Now moving on to the example on the right, we have if not of n not equal to n not equal to 4. And we can start off by just evaluating the first thing here, which is 9 not equal to 4. And 9 obviously is not equal to 4, so that is going to be a false. Sorry, that's true. So since 9 is not equal to 4, and then not of true will be false. So if it's if false, we're going to go and print if executed. But since it's false, we're going to move on here, and we're going to go to if 9 is less than 4 or 4 is less than 2. Once again, 9 is less than 4. That is false. And then it's or, and 4 is less than 2. That's also false. So this whole thing equates to false. So then we're going to go and move on to the next statement, which is the else statement, which is the last thing that this whole block of code will resort to. And that is to print negative. So as you can see here, the output will be negative. And yeah, so essentially both of these statements run on Boolean Algebra, which is what your conditionals could run on. However, there's many other forms. You don't have to use numbers in general. You can just use Booleans. You can use other statements. You can compare strings. You can compare different variables. So this is just like some basic examples of how conditionals work in Java.
All right, so now we'll be talking about loops, and loops in code are essentially, they allow us to repeat a segment of code a certain number of times, and loops are very commonly used and essential to many programs. And three main types of loops that we'll be using while coding are for loops, while loops, and do while loops, with the most common being the for loop, and the while and do while loop being less common, but they're still utilized when coding, and we'll be taking a look at each of them in detail now.
Okay, so the first loop is the for loop, and the for loop essentially allows us to repeat a certain code segment a certain number of times, which is defined by the limit. And the general format for a for loop, right, the header of a for loop is for parentheses int I equal to 0. I is less than your variable or a certain number of the number of times you want to repeat it, and your incrementer, which is your I plus plus. And let's go and break this down step by step. So the first statement, the int I equal to 0. So this is essentially the counter variable in your loop. And we declared at 0 in this example, but you can basically have it to any number that you'd like to start it at, depending on your situation and what you're programming. So this is essentially the variable that will be used as your counter variable. The next statement is the I is less than num times to repeat. This is the limit, I would like to call it. This is basically to check to see when your loop will be complete. So this is basically saying so you'll be running this loop until the I variable is less than whatever value is here. Until the I variable is less than the num times to repeat. And the last one is the I plus plus, which is the increment, which will essentially increment your counter variable. So it's I plus plus, which is essentially equal to I plus equal to 1. However, you can always increment this by a separate value. You can do I plus equal 3, I plus equal 4, I plus equal to 5, which essentially incremented by a certain number each time you go through this loop. So that's a basic overview of the general format for a header of the for loop. And then you have your two curly braces after this. And then you just add whatever code you'd like to add inside the body of the for loop. On the right, we have some examples. And you can see a fully implemented for loop over here, where we start at int I. We initialize int I equal to 0. I is less than 5, so we'll be doing whatever's inside the body until I is less than 5, and we'll be incrementing I after each time we go through this body. Just as a heads up, you don't have to say int I equal to 0. You can put any other variable name you like here, and you can also declare int I or int x before the for loop. So you can just say I is equal to 0, but you have to make sure that you've declared it before. Yeah, so let's go ahead and work this through. So I is equal to 0. Our first pass will print out I, and since I is 0, you'll get 0 as your first pass. Your second pass, after it prints out 0, it'll increment. So now I will be equal to 1. It checks, is 1 less than 5? Yes, it is. So then it'll go through again. It'll print out 1, right? Then it'll go through again. I will increment. I will become 2 now. 2 is less than 5. That's correct. We'll keep on going like that until you reach the value 4. So now, at the value of 3, it'll increment, go on to become the value of 4. It'll print out 4, and then it'll increment. And then when the value becomes 5, it'll check, is 5 less than 5? That is not correct. So then it'll stop. And this will be your corresponding output, which is 0 space 1 space 2 space 3 space 4 space. And yeah, so that's essentially how a for loop works in Java. So once again, if you guys have any questions, please write them down in the chat, or if you're comfortable, please voice out through your microphones. Okay, so now we'll move on to the next slide. So these are while loops in Java. So while loops are essentially allow us to repeat a certain code segment until a certain condition is met. So you could sort of relate them to for loops, but they have their own differences. So the general header is the biggest difference. It's essentially while parentheses a Boolean condition. So remember, the condition inside of these parentheses has to be a Boolean condition. Otherwise, you'll run into some compiler errors. And note that in order for this condition to be met, the condition has to be able to be met, right? You can't put in a condition that can never be met, or else what will end up happening is if the condition can never be met, then the loop will keep on going on forever and ever, which is sort of known as an infinite loop, and that will go on and crash your program. That's something that you do not want. So make sure that whatever condition you place inside of this while loop can be met in a certain number of increments or stuff like that. So on the right, you can see an implementation of the while loop. So here we declare, we initialize a value of int I equal to 0. And we're essentially doing the same thing we did in the previous slide with the for loop, except we're doing the same thing except with the while loop. So sort of show how it works. So we say int I equals 0, we initialize it there, and then we say while I is not equal to 5, right? Which is essentially saying while I is not equal to 5, we're gonna go ahead and print out I plus a space. And then after we print that out, we're gonna go and increment it manually, the value of I, and it's gonna go back in. So for example, we go into, we start with the value 0. 0 is not equal to 5. That's true. So then we'll go ahead and print out 0. Then we increment. I becomes 1. 1 goes back in. 1 is not equal to 5. 1 is not equal to 5. That's correct. It'll print and go so on till the value of 4. It'll print out 4. 4 will increment and become 5. While 5 is not equal to 5, well, 5 is equal to 5. So that will become false. So once that equals false, it will break the while loop, and then this will be your corresponding output. So that's basically a simple example of how while loops work. Once again, you do not have to have numerical implementations. You can use any other variable, but you have to ensure that whatever condition you're placing inside of that while loop, it has to be a Boolean condition.
Yeah, all right. So the last type of loop we have is the do while loop, and do while loops are very similar to while loops, but the difference being as a do while loop runs at least once and is guaranteed to run at least once, whereas a while loop might not even run once if the condition inside of it starts off as false. So the general header for a do while loop is you have your do at the start, and then you have curly bracket area of the brackets, and then you have a loop body inside of that with all your code. And then after that, you close the braces, and then you have your while condition, and then you put a semicolon at the end. And essentially what it does is the loop repeats the code inside of the do body at the very start. And then after that, it checks if the while condition is true. And if it isn't, then it repeats the code inside the body again, and keeps on doing this and repeating this cycle until the while condition is met. And note that similar to a while loop, it's important to ensure that the do while loop is not infinite, so that because if it is infinite, it might crash your program, and that won't be good. So running through this example, we start off by declaring an integer I as 0 as our counter variable. And then we enter the loop body at the very start and we print out I, and then we increment I. So it prints out 0 and then it increments I to 1. And then it does that again and again and again. And it increments I up till 4. And then once it reaches 4, we print out 4, right? And then we increment I to 5. And then after that, it checks, is I equals to 5? And since it is, it doesn't go ahead and enter the loop body again. So the loop terminates there.
Okay, yeah. So that was basically like a quick brief overview of just conditional statements and loops in Java in general. So as I mentioned before, this week we'll just be primarily focusing on review of basic Java concepts before we move into more complex Java concepts that are essentially embody the APCS curriculum. So with that, that concludes day 1 of our intermediate session. So if you guys have any questions, I will go ahead and stop our recording for today, and we'll be there to answer any questions if you guys have any.